All right, so this is target 6C, and we are talking about congruence and defining congruence as equality of shape and size. So, your objectives for this lesson are to determine what can and cannot be assumed from geometric diagrams. You will be able to identify tick marks and notations on geometric shapes that will help determine congruence, and you will be able to use information about congruent figures to solve algebraic problems. All right, so let's start off with what can't you assume from geometry diagrams. Okay, don't assume that the diagram is drawn to scale. For example, look at the figure to the left. What shape would you assume that this is? Most of you would probably say, oh, that's a square. However, there is no information given in this regarding the lengths of the sides, the measurements of the angles, so you can't assume it's a square. You can't even assume it's a rectangle. The most you could assume is that it's a quadrilateral. Okay, because it doesn't have any kind of defining characteristics listed. It could be any one of those listed, and that's just a few of the options. Okay, don't assume any angle measurements. Okay, although that shape looks like a rectangle, can you assume it is? No. Okay, there aren't any markings in the corners to tell you that those are 90-degree angles, which it would have to be if it's a rectangle. Now, if you put these squares here in the corner, such as this, you've got these here and there. Okay, that tells you that those lines are perpendicular and those are 90-degree angles. So now that we have that information, we would be able to say that it was a rectangle. Okay, also don't assume that any lengths are equal. A and B and C and D may look like they're equal. Can you assume that they are though? Again, no. Okay, unless they have these markings. Okay, see these tick marks or the notation on the line? If they have the same marking, then you can say that those are congruent. So say I put a tick mark there and one there. Then I could say that AB would be congruent to CD. If I put two there and one there, that tells me that they are not congruent. Okay? Okay, so now let's go on to what we can assume from geometry diagrams. So you can assume that any line or line segment that looks straight is straight. So for example, we can be guaranteed that because there's a line drawn through D, E, and F, that is a straight line. Same with C, E, and G. That is a straight line. Okay, so you can assume collinearity. All right? If it looks straight, it is straight. Basically what it is. Moving right along. So in a nutshell, I made this list, and you might want to copy this down. Interpreting a diagram, things you should assume, things you should not assume. You can assume straight lines and angles. And what I mean by an angle is, okay, here's a straight line. If I put a point here and here, and I label that AB, you can assume that's a straight line. If I do this, ABC, then I can assume that's angle ABC. I can't assume any measurements from it, but I can assume that it's an angle. Collinearity of points, again, if I put a point here, I can assume that A, E, and B are congruent. Betweenness of points, I can assume that E is between A and B, and then the relative position, like I could put a point up here and say, well, D is above line AEB. So you can't be tricked that way. But again, you can't assume right angles. You can't assume congruent segments. You can't assume congruent angles. And you can't assume the relative size or measurements of segments and angles. So don't try to. All right, so let's talk about congruence. Objects that are exactly the same size and shape are said to be congruent. And this is going to be the symbol that you use to show congruence. So like if I label this triangle A and this one up here B, I could say that triangle A is congruent to triangle B. Okay? If I was given that the triangles are congruent. Right now, all I'm showing here is that these sides are congruent and that these angles are congruent. Okay? All right, moving right along. When you look at congruent figures, you want to find the sides and angles that match up. Sides and angles that match up there are called corresponding corresponding sides and corresponding angles. So in congruent figures, these corresponding parts are also going to be congruent. So if I give you two triangles and I say that they're congruent, then the matching parts of those triangles are also congruent. Okay, so for example, here I can say that segment BC is congruent to segment EF because they have the tick marks. What else can I say? What else can I say? I could say that segment AB is congruent to segment DE, and I can say that segment AC is congruent to segment DF because these triangles are congruent. So if I was told that triangle ACB is congruent to triangle DFE, that means that the angle at A would correspond to the angle at D. The angle at C would correspond to the angle at F. Angle at B would correspond to the angle at E. AC would be congruent to DF, so on and so forth. Okay, so again, angle C and angle F, angle B and angle E, and angle A and angle D. So now I'm telling you that these two triangles are congruent. DEF is congruent to triangle KJI. Now the triangles don't look they are not in the exact same position. So you have to go by the information that you're given. So you're given that triangle DEF is congruent to KJI, which means that D and K are congruent. Let me change the color of this a little bit. So that means that this is congruent to this, and then the next letter is E, which means I'm going that way. The next letter for this one is J. So basically, if I was to follow that along, that means that E and J are congruent, F and I are congruent, and even though it's this segment, for example, DF is on the base of this triangle here, this base is towards the top. So again, segment FD, IK would be congruent to that. If you have these two diagrams, even though the triangles don't look like they're congruent, because of the markings on them, we would say that they are. So if BAC is congruent to LMN, which ones are, which parts are congruent? So what would be congruent to angle A? Well, if I look up here, A is right in the middle. So if I go to the middle of the next one, angle M, that would be the congruent part. All right, so now we're going to use information to solve for a variable. So we are given that these triangles are congruent. ABC, which I'm going to have to label this for you guys. So if we're given that ABC is congruent to DEF, and I want to find the value of X. So I know that angle A is 88 and angle D is 22x. So I can just set that up so that 22x equals 88, and then just solve like you would have been for the entire first semester. Divide both sides by 22. You get x equals 4. You find the value of y. So we've got this equation, or not equation, we've got this expression, 4y minus 12. Okay, and the corresponding part would be the 20. So since those triangles are congruent, those parts are congruent, so we can say that 4y equals 12, or 4y minus 12 equals 20, and then just solve it algebraically. Add 12 to both sides, so these are 4y equals 32, divide both sides by 4, and you get y equals 8. All right, you try this one. So find the value of x, find the value of y. So I want you to pause it, make sure you're taking notes on this, and solve the problem. So if you've done this, you would see that 18x equals 126 because those triangles are congruent. Divide both sides by 18, and you get an x equals 7. For y, negative 12y plus 4 equals 100. Subtract 4 from both sides to get negative 12y equals 96. Divide both sides by negative 12, you get y equals, and that should be a negative 8. All right. And that is it. So this is going to start getting a little bit more difficult, but I have faith that you guys will persevere and stick with it. Keep taking notes. Don't fall behind on this stuff, and you will be fine, I promise.